Hello everyone, this is Mansi from the Department of CSCEI from Sri Venkateswara College of Engineering. So today we'll learn about what is a support vector machine, shortly known as SVM, which comes under the topic of machine learning. So let's begin with the video. Topics that are gonna cover in this video are introduction to SVM, how does it works, SVM parameters, what are the disadvantages and advantages, application, variants, and conclusion. So let's begin with the introduction. Introduction to SVM. SVM, it is a powerful machine learning algorithm. It is used for classification and regression tasks. It is mostly used for classification problem such as text classification, image classification, and in bioinformation informatics. So an SVM algorithm, we plot each data item as a point in n dimensional space, where n is a number of features you have, with the value of each features being the value of a particular coordinator. When we perform a classification by finding the optimal hyperplane that differentiates the two classes very well. So how does SVM work? Support vector machine is a binary classifier that separates the data into two classes by finding the hyperplane that maximizes the margin between the two classes. So the margin is the distance between the hyperplane and the closest data points from each class. And SVM can handle non-linearly separable data by transforming the data into higher dimensional space. So in scenario one, we identify the right hyperplane. Here we have three hyperplanes, that is A, B, C. So now we identify the right hyperplane to classify the stars and circles. So select the hyperplane which segregates two classes better. In this scenario, the hyperplane B has excellently performed its job, that can easily differentiate between two classes, that is the star class and the circle class. So how does this SVM, that is support vector machine, actually work? So first step is identifying the right hyperplane. So here we have three hyperplanes, that is A, B, C, and all segregates the classes very well. However, how now how can we identify the right hyperplane? Here is to maximize the distance between the nearest data point, and the hyperplane will help us decide the right hyperplane. The distance is called as margin. So here you can see the margin for three hyperplane. C is the high compared to both A and B. So we name the right hyperplane as C. Another lightning reason for selecting the hyperplane with a higher margin is robustness. So if we select the hyperplane having the low margin, then there are high chances of miscalculations, misclassifications. So in this scenario below, we can't have a linear hyperplane between the two classes. So how does SVM classify these two classes? Until now, we have only looked into the linear hyperplane. So SVM can solve this problem easily. It solves the problem by introducing additional features. So here we will add new features. That is Z is equal to x square plus y square. Now let's plot the data points on axis x and z. In this plot, point to consider are all the values of z are always to be positive, because z is squared sum of both x and y. In the original plot, red circles appear close to the origin, to the x and y axes, leading to lower value of z. The star is relatively away from the original results due to the higher value of z. So now let's discuss that SVM parameters. C is a regularization parameter that controls the trade-off between maximizing the margin and minimizing the classification errors. Gamma is a parameter that controls the shape of the boundary decision boundary. High gamma value leads to more complex decision boundaries. Kernel function is a function that transforms the input data into higher dimensional space. Common kernel functions includes linear, polynomial, and radial basis functions. So, what are the advantages and disadvantages of using SVM, support vector machines? Our advantages is support vector machines can handle high dimensional data and largest data set efficiently, and support vector machine is robust to overfitting due to the ability to control the complexity of the decision boundary. So SVM can handle non-linear separable data by using kernel functions. And some of the disadvantages of using support vector machine is SVM is sensitive to choice of kernel functions and its parameters. SVM can be computably expensive for larger data sets and complex kernel functions. SVM does not provide the probabilistic of outputs, which may be necessary for certain applications. So some of the applications of using a support vector machine is first is image classification. SVM has been used to classify images based on their content, such as detecting objects in the image. And support vector machine is also used in text classification. That is, SVM has to be used to classify text document into different categories, such as spam filtering or sentiment analysis. So the third application of support vector machine would be bioinformatics. That is, support vector machine has been used to classify genes based on the expression pattern or predicts protein interactions. So variants of SVM. So there are different variants of support vector machine. First would be one class support vector machine used for anomaly detection by finding the hyperplane that encloses the single class of data inputs. So support vector regressions used for regression task by finding the hyperplane that maximize the distance between predicted value and actual value. And the third will be multi-class SVM, used for multi-class classification by constructing multiple hyperplanes to separate the different classes. So let's jump into the conclusion that support vector machine is the most powerful machine learning algorithm that can handle high dimensional data and larger data set efficiently. SVM can handle non-linear separable data by using kernel functions, SVM. That is, support vector machine has variety of application and fields such as image classification, text classification, and in bioinformatics. Thank you for watching the video.